Fine. So today I'm going to be talking about Docker containers. My name is Jeff Semmens. I'm a senior sales engineer with InterSystems. Basically, it just means that I've been here a long time. How many people already have some experience using containers? A few? Okay, so we have 4 or 5, maybe 6. For those of you who already have done a lot of things with containers, the first part of this is going to be pretty much review of things that you already know. But for those who don't, it's going to be hopefully a good foundation for what containers are and how they might help you as they go forward. My agenda is pretty much this. I want to help you to try to understand a little bit about what Docker is and what Docker containers are in particular. And then I want to go into more of how InterSystems is starting to go into the container world and what kind of support we're going to have in that going forward. And then the last of it is why that might be important to you as a development group or as a end user group that has to put things into production or take them out, that type of thing. So let's get going. What is Docker? Well, Docker is basically a way to package up an application and all of its dependencies, whether it's application, cache, or InterSystems Iris or Ensemble or other things that we're going to have as container images that you can download. Maybe Apache, maybe a Linux or some sort of distribution that you're going to have in, and allow you to create what Docker calls an image for that. That image is a definition that Docker uses, which then allows you to deploy that exact image with all the same dependencies, with all the same libraries, with all the same code, to different platforms that support Docker containers. Those platforms are Mac, Windows, and Linux. Windows is a little bit different. They pretty much do it the same way, but of course they do things a little bit differently. But an image that you create on these can be pretty much put anywhere else you want. So on my Mac, I can have Docker running. I can pull an image in that would work on any Linux machine or anything else that we do in that way. From there, we basically have all the containers ready that we can then run on those different platforms. Comparison with VMs. Containers have always done about similar things to VMs, right? But it is different. A VM, you have basically some sort of hardware server. You have a host OS on there. You then have your hypervisor. You then have a guest operating system on top of that also has to be installed and managed and run. And then on top of that, you have your different libraries and binaries and then your application code. With containers, it's a bit different. You have a much thinner layers because there is no hypervisor on top of things and you don't have to have a guest OS. The container runs natively on the host OS on top of the server. And it's been built into Linux for quite a few years now, different container support. It's really been in the last couple years with Docker and a few other companies coming out with ways to make this much easier, that the containers have really started to hit their stride as they go forward. How do they work? Well, a container basically allocates, this is done at the kernel level in Linux or on a Mac or Windows, as I said before. And the container itself will allocate CPU timeshares, memory, storage, network bandwidth, pretty much anything that you would think of that needs to be used in this sort of sandboxed environment. The characteristics is that the kernel handles the containers. There's a lightweight service versus the full stack. There's a higher packing factor and a lot less idleness involved. And plus, you can really have a quick startup. If you're starting up a new VM, I used to be in VMs all the time. I'd have a VM for a different customer. And whenever I want to work on that customer, I have to start up that VM. I'd have to wait for it to boot. I have to get into it. And maybe something's changed on there where there's been some sort of Windows update or something that I didn't know about that it starts to take off and do things. Containers is much different than that. You pretty much have the image. You build that image to the spec that you want, and then you run that image. At that point, it takes usually less than a second to actually run a container and get it up and going. So you can have very quick updates and getting to the tasks that you want to do. For myself now, for customers, instead of creating a VM or creating just an instance on my own machine where I do things, where I'd have to load in code and compile it, now when I'm working with that customer, I create a new container. I pull everything in that I need for that customer. I compile it down, and then I save that image so that the next time I want to work with that customer, within about a second, I can bring up their exact environment and start working on it. It also works really well for development groups. If you want to take a certain environment that you're building an application and have someone else look at it, you can actually give them the image so that they can spin up the same exact thing. Or vice versa, you can send it to your testing group. And if there's an issue, well, you know that that issue is in the exact same environment that you have. There's no OS patching that you have to worry about. You don't have to worry about AWS putting it in a little different version up there when you're testing things out. It's all contained. We can talk a little bit about storage. There's really 3 different ways that containers do storage. One is that it's stored within the container image itself as a version. So at any point I can say I want to build a container and I want to give it a name and a version. So I have my app of version 1. I then say, well, now I want to make a few changes, and I can create a version 2 of that app. So now I can have 2 different images, one version 1, version 2. All the storage is internally to those actual containers themselves. So if I want to go roll back to version 1, I just stop that container and I bring up container version 1 instead, and now I'm back in that same environment that I started in. There's also the idea of shared containers or container volumes. So this is the idea where I have a container, maybe multiple containers, but they want to be able to share the same data. So there's a way to specify and say that I want to share within the container definition itself, within the storage that's part of the container environment, if you will, data across these different things. So there's different commands in the command line that allows you to say, all right, I want to start this, I want to build this container, but I also want to actually use a volume from another container that maybe its sole job is just to be a container between other containers and things like that. So there's a lot of different opportunities you have there to do that. And the last one is that you can have a host volume. So there's nothing to stop you from saying, yeah, all this stuff is saved into my image, but some of that information is stuff that isn't part of my code, say. Maybe it's real data like in a database. And I want to store that, and I want to do things with that. But if this container goes away, I don't want that data to go away because that's really important to me. It's not like code where if it goes away, I can bring it back up in the same state again. You know, data is changing. It's something that's dynamic and not something that should just go away. The idea behind this is that I can run my container and I can say, I can give it a specific volume and say that on my host machine, I have my database here, and then inside of my Docker container, I just reference it by a different path inside. We can do the same thing with ports. We can do the same thing with a number of other things so that this container can see to the outside world and vice versa. All the security is handled by the kernel OS itself, a number of things like that. I'm not going to go into huge details on all the ideas about Docker containers, just because there are great resources. If you go to docker.com, there are great learning resources and everything else to come up to speed on this. You know, consider this like another platform. If you were going from Windows to Linux or something like that, you'd have to understand that environment before you really want to do it. And this is the same with Docker. You know, if you are going to start looking at containers, go and find out how containers work. What you'll find is that we are supporting them in the way that Docker thinks that they should be supported. Let's do a quick little demo. On my system, I have Docker installed on my Mac, and I just want to do a very simple situation here. So I'm going to bring up just a command prompt. One of the things you'll find out with Docker is that there is a command line interface to do almost everything. There's not a lot of GUI stuff for it because that's not how it was made. It's made to be more of a command line interface to actually do things. So what I'm going to do right now is I am going to put in a command to run a Docker container that I don't even have on my machine. It's going to go and find it. Well, actually, it's going to figure out, oh, I don't have it on my machine, and then it's going to go find it up on the internet. It's going to pull down that image, and then it's going to run it for me. It just so happens there's a nice hello world thing on the Docker Hub thing. It's a container. Notice that it couldn't find it locally, so it went ahead and pulled the latest one. The nice thing about containers also is that they they stack up if you have multiple things that you're pulling from in your image. So maybe I'm not just pulling this thing, but I'm pulling maybe Apache, and maybe I'm pulling Ubuntu, or I'm pulling some other container images to be part of my new image. As those change and I rebuild my image, it'll go out, if you tell it to find the latest one that it's going to pull down, and it can actually upgrade those parts of your image as it's building it the next time, which is pretty cool. So what this did is it downloaded it, it ran it, and then it finished. There's a nice little command that says, okay, well, what's running in my Docker system? So I can say Docker PS, and it says nothing's running. Well, why is that? The main job of a container is to spin up, do its work, and go away. So it did that. Now there's another command that I can do here, say Docker PS-A, which says, don't just show me the running ones, but show me all the processes in the background. And I have one sitting out there. Notice that it said that it exited about a minute ago, which is true. It did its job, and then it went away. I can run this again right now. I can say Docker, run, hello world. Notice that it went a lot quicker this time because it didn't have to pull the image. This time it says, oh, I had that locally. I can just run this thing. So that's sort of the whole idea behind it. Again, if I do my PS, I'm not going to see it because, again, it did its job. Does that make sense so far? Okay. I can also pull down, say, Ubuntu if I want to, and shell into it and do different things. You can run it interactively so it's not going to go away and do things, or you can keep it as is. So that's demo 1, the Hello World demo. Always unsatisfying, but hopefully shows you something. So let's talk a little bit about InterSystems and Docker and what we're going to be doing, and what we currently actually do. So the whole idea behind building an image, I guess I'll give a little bit more background before I talk about how we do it. Everything that we build to build an image, when you're building an image with Docker, starts with a definition called a Docker file. That's a very simple language that basically says, how do you want to build it? You know, I have a very simple one here that I'm about to build using one of our images internally that all it does is pull our image, copy a key into that image, and build it. Boom, done. It's a lot simpler to do this now than to download my latest build in like a tar form, install it on my Mac, get all the ports set up, do all the things I want to do, copy the keys in, do that. Now I can just pull the image and the whole install is done for me basically. I can just run that image or build that image and then copy in the different stuff I need and do the other things that I need to do on it. So the whole idea is that you have a Docker file, which is sort of the definition. You then build from that definition, which creates this Docker image. It contains everything necessary to run that. And then you basically, when you're running it, you say, I want to run the image to create the container. It's a runtime version. You have different parameters to handle networking, storage, ports, cache and InterSystems Iris and Ensemble parameters, all the different things that you could think of. So what are we doing? Well, what we're going to provide are base images for cache, Ensemble, and InterSystems Iris with them already installed. I'm not sure about my English there. I'll have to I think I was editing it before the session, so it may not be exactly great. We're going to be doing this from official container repositories. As you get into Docker, you'll find out that there are official repositories out there. You can also have your own sort of local ones. Right now, I've been pulling them from our own internal ones that only we can get to because we haven't released it yet. But we will, the plan is to have those in some official Docker repositories that customers can actually pull from. Those will be versioned, they will have security around them so that when you pull them, they are the right one, that it is from us, it's sort of signed, all that sort of built into the infrastructure of the Docker world. And then from there, the user, you will be able to configure your key, your code, your different configuration. We've also added in some new capabilities just recently called durable, well, internally we call it durable %sys. Basically what it allows you to do is take all of those things that are changing on a database system that should not go away when a container exits and allows you to have those external on the host OS itself. Those can be like your CPF file, your key, your journaling file, your widge, there's probably a whole bunch of other ones, and they're all documented pretty well. But it allows you to really keep your code base in the container so that it can be versioned and automatically upgraded, and all the things that should not be upgraded in that manner that are really data and customer specific can be saved in a different location on the host OS, so you can actually handle that with source control or whatever you want to do. We've actually been testing Docker containers since 2015-1. There's been nothing to stop you from using an InterSystems cache or ensemble within a Docker image since that time. You just had to build the image yourself. So you would have to pull down, say, Ubuntu, which is what we're using as our OS on these containers, and you would have to install your cache version or an ensemble version, and then save your image in so that it would save everything that you want in there into that image. There's nothing to stop you from doing that. There's some good articles on the community, the developer community, which actually take you through doing that for things, and it's certainly a valid way. The big thing we're bringing now is %durable sys, or durable %sys. I think that's my dyslexia coming in. I start flipping things around when I talk fast. And then the other piece is having the images that you can actually download and pull. So the advantages of public container images, you don't need to start the OS, or you don't need to start from an OS installation, right? And then you don't need to bring gigabytes of OS distributions. You basically just download or pull the image itself that we give you. There are going to be different versions of that. Right now it has everything that you would have in a normal cache system, but at some point we're probably going to version that also and say, here's a production one that doesn't have samples and doesn't have all this extra stuff that you need. So it's a much smaller, much leaner image that we're going to give you. Right now our image is a little bigger than we want in some cases. For development it's fine because you have everything you need, but for more production stuff we're going to handle that in a much better way. So you don't need, with the InterSystems-based images, you don't need to install Cache, Ensemble, InterSystems Iris, any of those things. We also, for a container to stay up, it needs to be doing something, right? So the hello world, it came up, it did its job, and it went away. So we have a little program called ccontainer-main that runs. And that is what keeps, it runs as PID1, so it basically keeps the session alive while the container is started. So you can do everything to it. It does a number of other things, which I'll cover in a minute, but that's the main thing that we want to do. You only add what's needed, your application code, your key, your dependencies, and again, the pull location is going to be a major Docker API compliant repository. Question, real quick?
Is there an image for health share? Or a way
So the question is there an image for health share? Not yet. That will be coming at some point, especially with the InterSystems Irish, boy. Hey, matey. Especially with that, when we have the healthcare version of that, that'll certainly be a container version of that on there. So ccontainer-main, it does a little bit more. So it is authored and supported code by us at InterSystems. It correctly starts the InterSystems instance, whether that's Cache, Ensemble, whatever. It also correctly shuts down those instances when you stop the container. So if I do a Docker container stop of whatever container I have running right then, which has Cache, ccontainer-main says, okay, I see that you want to stop this thing. Let's go ahead and bring down Cache correctly. So you don't, just like cut the power on a server. It's sort of like what you would do if you didn't have ccontainer-main or something else in there to handle that job for you.
Would this be more from a development perspective, or would you recommend running containers in an actual production environment?
So the question was, would we look at this more in development or an actual production environment? I think the short answer is it's really going to be both, and it's going to depend on what you need to do and what you're doing and what your application looks like. At the end, we're going to have a little more time for questions, and we're trying to record this, so we have a microphone that we'll probably pass around too. That way I don't have to repeat your question and sound really dorky and that type of thing. So, all right, let's get into another demo. So what I'm going to do is just create an image real quick with the InterSystems Iris stuff. And I have my hello world. Let's see, what directory am I on? I need to switch directories. Oops. Okay, so I have a directory here that has one of these Docker files. The Docker file is very simple. It basically has 2 lines in it. It says that I want to pull with my username. I want to, wait, there it is. So the first line just says from InterSystems ISC Iris Global Summit 2017. And I need to push that up to the top because, is that better? All right, sorry about that. You know, are you the one who actually, there was someone actually recommended me I do that yesterday and I totally forgot. So if you're in here, I really apologize for ignoring what you told me to do yesterday, but okay. So it really has 2 different things that it's doing. It basically pulls from the InterSystems Iris and then it, wait, where did I lose it? Oh, and then copies my key. So there's 2 things that it's doing here. So all I'm doing is I'm pulling an image that's already got it installed, and I'm copying a key to it so that I can actually access it. There are tons of other commands and other parameters you can use when building these things. Docker has awesome learning resources and really good classes and things like that that you can take to actually come to speed very quickly on this. There's also some great videos and things like, I think one of my favorite for just understanding containers was Docker Containers 101 for Windows. You know, even though I don't use Windows, he just he said all the, he explained all the concepts very, very well, which was very nice. So what I'm doing here is I'm just going to go ahead and build this, and since I have a terrible memory as I get older, I'm going to go ahead and just grab the actual command from here. It's very simple. So what am I doing here? I'm basically calling the Docker build command. I'm saying go ahead and make it, I forget what -t does because you know I've just used it. There's tons of samples and they always have -t. You could look it up in about 2 seconds, but I don't feel like it, so I'm not going to. I'm going to call this Jeff Iris for version 1, and it should look in the current directory for the Docker file and anything else that needs to build this. If I hit this, it basically says, okay, I want to grab the InterSystems ISC Iris. Now, I downloaded this prior because right now this is about 1 gig or something like that, for that image to pull, so it would have taken a minute or 2. And on the hotel network, I'm not sure how long that would have taken. At home, at my 300 megabit up and down, it takes about 3 minutes. The next thing it did was copy the key, and then it says, all right, I am all set, I'm successfully built, and I've tagged it as Jeff Iris version 1. If I take a look at my images, I can see that I have a few here. I actually downloaded Ubuntu earlier. You know, that's like 120 megabytes. I have the Hello World one still there, even though it's not running at the moment. I have a couple other ones, but I also have the Jeff Iris version 1 that said it was created 36 seconds ago. Next thing I want to do now that I have this image built is I want to actually run it. So let's go ahead and do that. I go back to my notes here. I have this nice little thing. Copy. So in this case, what I'm saying is I want to run the image Jeff Iris version 1. I want to name it Jeff Iris, and I want to do a couple ports. I want to do, if I have port 57772 on the inside, I want to also use that in my host OS to reference it. So you have a nice mapping between your host OS and the ports on the other. Those could be different numbers. Like internally it could be, since this is a default install, it would be 57772, but maybe on my host OS I'm already using that, so I want to give it a different version. Same thing with 1972. So I'm basically opening up both ports so I can do things with it. If I hit run on it, it's like, okay, it says it's running. Here's this huge key about how it's running. And now if I do docker ps, notice that it is running C container main. It's been up 8 seconds and it's still running. So that's great. Well, what do I want to do with that? Well, what's the first thing I usually want to do? I want to pull up a browser and I want to go to the system management portal for it, right? And since I mapped it to 57772, oops, let me log out and log back in as an actual user. I can get right into my system management portal and I can go and say, I don't know, let's go to SQL, let's go to the samples namespace, which is in here at the moment. Let's take a look at all my sample tables. Let's take a look at my sample person table since that's my default go-to thing. And here I have a name of Ted King in there. So I can see my data that's in my container. It's running. I can also go into, say, Atelier, do the same type of thing. So let's go into Atelier. It's going into my local workspace. By the way, do we have a lot of people using Atelier yet? Couple? I've been using it over a year now because, especially on a Mac, I didn't want to go into any virtual machine ever again, and I will not go back. Does it have everything yet? No. Has it been that big of an issue for me yet? No. I can work with it. So I'm a happy camper that way. So here we are in Atelier. It just so happens that I already have a server set up that is set up for that. If I double click on it, I can bring up the definition, and it just says, go to my local host on my host OS here, go to that port 57772, which I mapped, and I have a login. I can test my connection. Oh, look, I'm successful. That's always good when you're successful. I can then open up that container. I can look at the samples namespace. I can look at the different classes in there. I can go down to my sample and person class that I was dealing with. I can open it up somewhere. Where is it? And if I want to, I can pull that into a project on my side and work with it. So again, I haven't done a lot of work. All I did was pull an image that's already built. It happened to have samples in it. Sure, I'd have to do some work to load my own data and everything into it, but it's all there. So the last thing I want to do is maybe I want to get into the terminal on it. So let's go ahead and I'm just going to go ahead and start a shell that's connecting to my Jeff Iris. So this is a Docker command. And just executing that. I'm executing it you'll see what the commands are. I'm not going to go through commands. But I'm basically at root now on this thing. Now, there are security concerns, of course, and there are ways to keep this from happening so that people can't get into root on your system and stuff like that. But it's the whole idea that even if you're on VMs and stuff, half the time you have the same security concerns that you would. Now that I'm in here, I can do C session cache. Oops, no, it's Iris. Wait, what is it? Let's see. Okay, it's Iris. C session. And I can type in my username. And I can go to, say, samples. And I can say set person equal to class. Oh boy, my typing is bad. Open up the first one. See that, yeah, that's really Ted King still, so let's change that. Not that I'm self-promoting. And save it. All right, now if I go back to here and I refresh it, sure enough, it's updated, good. Now, have I really saved this data? Yeah, it's in the database in the container, right? What happens if I stop this container though? So let's halt out of here. And we can even close this up a little bit. And maybe stop Atelier for the moment because I don't need it anymore. So what happens if I stop this container? So let's go Docker, stop Jeff Iris. Now this is where the C container main is saying, oh, he wants to shut down the Iris version, so I better make sure it goes down through the right shutdown stuff, which is why it's taking a little bit before it comes back and says I'm gone. So now I have to do Docker PS. It's not running, right? Well, what if I want to run it again? Oops, what did I do wrong? Oh, Docker container run, sorry. Oh, that's right, Docker container start. I have Luca in here because I am so forgetful. So here I just started up that same container, okay? Now if I go back into my system management portal, and it'll make me log in again because it went away, right? Oops. And if I go back into my tables again, go to my person class, open up the table, sure enough, it's still there. Well, why is that? Well, because in the running container, I have a storage. And in that storage is my database, and that's where I've saved my information. What happens, though, if I totally remove that container? I still have an image of it. Let's take a look. So I'll stop it, and then I'll actually remove it as a container. So it's now removed. Now if I take a look at running containers, or non-running containers, you can see it's not there anymore, right? So let's go ahead and run it again from the actual image. Now there's two things I want you to look at here. One is if I close this window and I go back here and hit on something. I didn't highlight it well enough, but this server name up here, I don't know if it's big enough for you to see, but that server name actually changed because I have a new image, this is a new container, and it automatically generated a new unique server name for that container. Okay. The second thing is if I go into that actual table still, you'll notice that I'm back to Ted King again, right? So the moral of the story is you need to, if you want to have your data persist through the loss of a container and you're going back to your image, then that needs to be externalized, right? So that's the whole idea behind being able to externalize your volumes and your databases. And that's also the reason why we allow you to map, or another good reason why we allow you to map your classes and your runtime, your routines to one physical database and your data to a second one. Because this gives you a perfect split between those two, the runnable version and the actual data of your customer, so that when you do versioning on this, you can actually upgrade very easily just by saying, pull the newer image that I want to upgrade to, and it should handle it for you. And then you run the extra script to recompile your code in the version that you need it to. All right, I'm probably taking too much time because I only have about 10 minutes left, and I want to leave time for questions. So let's go through the last part very quickly. Why this might be important for you. I think there's multiple reasons why. In development, I think you can see why. I've sort of stated it a couple times. You simplify the configuration. It really helps with the code pipeline management. Your developer productivity. I mean, as a developer, if I make a whole bunch of code and then I want to give it to someone to test out and they find an issue with it, wouldn't it be nice if I could just connect to their container where the issue is already broken and fix it there? And I know that I have everything in that environment that I had in the environment that I created it in because it's the same container or the same image that created it. Very nice things there. Same thing with when you go to production. You know, it's like you validated it in test. Well, you can take that same exact container. Nothing's changed in it because that's the whole idea behind containers. It's immutable. You can't change what's in the container when it's actually out there. You know, you have to physically, or you can't change the definition of it. You have to physically say, I want to commit those changes to the image before that would change. Application isolation, server consolidation, VMs compared to containers on the same hardware, we've seen ratios of maybe 2-to-1 containers over VMs, just because they use resources a little better. A little less than that maybe, so maybe if you had 4 VMs, you could get maybe 6 containers, but it really is going to depend on your application, that type of thing. Multi-tenancy, debugging, we talked about a lot of these. This really fits in well with the whole continuous integration, continuous delivery type thing, and we have other sessions here that are going to be going over this whole pipeline as well and the different aspects of it. You know, if you have your developer commit stuff into the source code repository, that then gets pulled, maybe pulled into Jenkins, which does a continuous, you know, I pull the latest InterSystems image, I then add our different stuff that we have from source control. It gets all compiled up automatically with our %installer stuff. Then Jenkins says, okay, it's done, let's go ahead and build this thing. It then builds the image, which allows us to then build the artifact, which is the Docker container, which then can be passed to test. Can be, once it passes everything, it goes back, and then go to production and forth. Questions? And if you have a question, let's try to pass around the microphone. I must also, if they get too hard, I'll bring Luca up too, as he's the product manager for this, for the Docker container stuff here at InterSystems. Luca, if you raise your hand real quick. So if you guys have other questions that are going to go really deep into it, Luke is definitely going to be your man to talk to in the next couple days. Any questions? Yeah? Yeah, it's right there. Yeah, you need exercise, Mike.
Okay, question. So when you use VMs, you run VMware or something. So is this, what's running the Docker thing?
Well, the Docker, it's a native function built into the Linux kernel, being able to do containers. Docker, what it does is it just makes it a lot easier to build and script these things. So it's sort of like a layer on top of that that allows you to, it's not quite orchestration, but it's more of how to build the container, how to do the other things. They've just put some really good client tools around that to make that much easier. And there are other parts of Docker that take it further. There's Docker Compose, which allows you to do a lot more stuff with simpler commands. So you can sort of batch up a lot of different things in the Compose itself so that when you're doing it, you just run the Compose command and that does a whole bunch of other Docker build or Docker run that you want to do as well. There's also on top of this different orchestration software that you can run on top of it to do things as well, to sort of orchestrate more things that are going on. Did I answer your question? Okay. Any others? Don't be shy about the microphone. We can always pass it around if you need to. Go ahead.
Okay, if you have a system in your Docker and you are using it, would it be possible to run UI from that?
To run a UI for
yes.
the stuff you're doing with Docker?
From your example, you had Ubuntu. Would it be possible to launch some UI from that? Some application like Chrome or Studio or whatever from the Ubuntu guest system.
I'm not sure if do you have a comment, Luca?
Yeah, I'm coming from.
All right, he's going to answer. Since I didn't follow it all, it's probably a good thing.
Yeah, so several people asked that about the UI. So let me try to answer the first question as well. So a VM is a full emulation of a machine. So we have an operating system that runs and fully emulate an operating system. So drivers, be able to see, and a CPU, address memory, etc. With Docker container, the isolation is much, much higher level. There's no emulation of an operating system. Okay, that's why when you saw Jeff's Docker images list, Ubuntu is 120 meg. Have you ever heard of a Linux distribution of 100 meg? It doesn't exist these days. It's about 4 to 10 gigabyte. All right. So we're not emulating anything. We're just saying there's a very thin layer that has basic a basic sustainability of an operating system. So you have /bin, /etc, /usr, etc. And there's no Unix Linux kernel. So the focus for container is on the application. I have my application, I have my cache, my ensemble, my InterSystems ARIS data platform, and I open a couple of sockets, and those endpoints are my application, the way I talk to my applications. So that's the main difference with VM, a full stack operating system emulating a real server. Why is that? Because typically to have to deal with an operating system is just a pain, right? Because I'm developing my application, why should I worry about an operating system? Let me add another switch to this, which is that's the reason why every public and private cloud now supports container services. In other words, they don't ask you to spin up any operating system. They say, give me a container, I'll run it for you. Done. I can focus, think about my application. So there's the advantages of this. To answer the second question on the UI, because it is not a full stack operating system, then you have issues in the way that we traditionally think about it. However, if you want like an editor, if you want some kind of UI, management UI, the best thing is to take like an NGX or an Apache container, so there will be like 50 megabyte, and then stuck in it like there's like Eclipse, CHE, Orion. There's definitely Cloud9 is another one. So you got several editors that allows you to basically talk directly to the container. They're browser-based, so you do exactly what Jeff has done today, right? Instead of 5772, they'll have 8080 port open. You connect to it, and you can edit file inside the container. Okay.
We have about 3 minutes left. Are there any other? Aha, we have a winner.
So is there any sort of a configuration file? So if I had a production instance, but I wanted to put it out here with, as a development instance with a different set of ports and host names, things like that. Is there a configuration file or something like that so I can just still maintain this base, but then I can change it on the fly without actually having to go in and manipulate that container over here in this location?
Right. Yeah. The configuration file is whatever tool you want to use. It could just be a very simple shell script, right? So your developer might just map, like Jeff did, like on 5772, because it's working locally. And when you go in pre-production, because you're working maybe on a private or public cloud and you have other ports, sockets open, you might map that to some other socket number. When you go to production, again, you have different choices. And this is part of the 12-factor application. If you look up Google 12-factor app, it basically says that you build your artifact, your image that has your application, and it's always the same. That's the point that Jeff was making right at the beginning, right? There is this consistency, a repeatability of building process, and a fundamental difference is between the build phase and then the run phase. And when you do the run phase, then you pass different parameters. So when you saw Jeff on his command line, when he did -p 5772, and you're in production, or maybe you want to use something else.
Okay, so so internal within that production config, so talking specifically about Ensemble, right? So I have hundreds of interfaces. So again, I start out with this base and the production host names and port numbers. When I stage it over here, I want a different set of host names and port numbers. So I wouldn't do that at the command line. There'd be some sort of...
Correct. That's why I said you'll have to script this.
Okay.
This thing, yes. So, I mean, nobody runs containers by hand, right? You might end up in a solution running a minimum of maybe 3 or 4 containers. So one is the Apache server with the CSP gateway install that talks to a cache ensemble InterSystems ARIS data platform on a particular port. You might have like a container that does monitoring for you, another container that offers some other services that you need. So you end up with 4 or 5 containers. Are you going to tap them all by hand? I don't think so. Right. So as a minimum, you'll have a shell script, and usually people start looking into orchestrators engine. So Kubernetes, Mesosphere, Nomad, Mantle, those type of solutions.
Thank you.
Okay.
About 30 seconds left. Any last? Otherwise, we will be around. Please feel free to find me. We have a couple other sessions as well. that are doing container stuff. So here's a little list for you. I'll leave that up on the screen. And otherwise, I will say, please complete the survey in the app. We really would appreciate that because we want to find out exactly how you felt. And then at the end, thank you.
Thanks.